From the searing heat of the sun to the heart of a volcano, fire is a force of nature that inspires both awe and fear. It is a destructive element capable of reducing forests to ash in a matter of hours. Yet, fire is also a force of creation, essential for the renewal and vitality of many of our planet's most diverse ecosystems. Join me, Shaheen Shahabi, as we explore the fascinating and often surprising ways in which fire shapes the natural world around us, in this episode of Facts with AI. Fire plays a vital role in maintaining the balance of many ecosystems. In the African savanna, fires clear dead vegetation, allowing new growth. This cycle stimulates seed germination and provides fresh grazing for herbivores. Without fire, grasslands would transform into dense woodlands. In North America, fire clears undergrowth, aiding towering trees. It creates canopy openings, fostering diverse plant species. Fire releases nitrogen, enriching the soil. Ash acts as a natural fertilizer, promoting new growth. While fire may seem destructive, it is essential for regeneration. Over millennia, certain species have adapted to survive fire. Some even depend on it for survival. Lodgepole pines need fire to release their seeds. Their resin-sealed cones open only in high heat. After a fire, seeds fall onto nutrient-rich soil. Eucalyptus trees also rely on fire. Their seeds germinate in the ash bed. Fire-resistant bark helps them survive. Fireweed blooms after a burn. Seeds wait for fire to germinate. These species show nature's adaptability. While humans are responsible for a significant portion of fires today, nature has its own ways of igniting the landscape. Lightning, a dramatic display of atmospheric electricity, is one of the most awe-inspiring and ancient causes of wildfires. A single bolt of lightning can generate temperatures hotter than the surface of the sun, instantly igniting dry vegetation and setting the stage for a wildfire. Wind, a constant variable in nature's equation, can quickly transform a small, smoldering ember into a raging inferno. It carries burning embers, sometimes for miles, spreading the fire far beyond its initial ignition point. In the dry forests of the American West, where lightning storms are common during the summer months, these naturally occurring fires have shaped the landscape for millennia. Native plant and animal communities have co-evolved with fire, developing strategies to survive and even thrive in its presence. While lightning-caused fires can be destructive, they're also an essential part of many ecosystems. Understanding the role of lightning in wildfire ignition is crucial for developing effective fire management strategies. While often perceived as a destructive force, fire can act as a natural form of pest control, keeping insect populations in check and preventing widespread outbreaks that could devastate entire ecosystems. In forests, fire helps to control populations of bark beetles, which can weaken and kill trees, making them more susceptible to disease and wildfire. These tiny insects burrow under the bark of trees, laying their eggs and feeding on the tree's nutrients. Over time, this infestation can weaken the tree, making it more vulnerable to fire. However, fire can also kill bark beetles and their larvae, preventing widespread infestations and promoting the overall health of the forest. Fire also plays a role in controlling populations of other forest pests, such as tent caterpillars and spruce budworms. These insects can defoliate trees, making them more susceptible to disease and drought. In grasslands, fire helps to control populations of ticks and other parasites that can carry diseases harmful to both wildlife and humans. By burning through tall grasses and brush, fire destroys tick habitat and reduces the risk of tick-borne illnesses. Over eons, animals have evolved remarkable adaptations to cope with fire. Some, like the black-backed woodpecker, turn fire into an advantage. This bird thrives in recently burned forests, feeding on insects. Deer and elk exploit fresh vegetation after a fire. They thrive in the mosaic of burned and unburned areas. Speed and agility are crucial for escaping flames. Birds fly while mammals find refuge in burrows or unburned patches. Some, like the kangaroo rat, survive the fire itself. These adaptations show life's resilience in the face of natural disasters. In the aftermath of a fire, a remarkable transformation takes place. What was once a blackened wasteland gradually gives way to a vibrant tapestry of new life. The first signs of life to emerge are often the pioneers' fast-growing plants like fireweed and grasses, their seeds carried by the wind or lying dormant in the soil, waiting for the opportunity to flourish. These early colonizers stabilize the soil, preventing erosion and creating favorable conditions for other plants to establish themselves. As time passes, shrubs and young trees begin to take root, their growth fueled by the nutrient-rich ash left behind by the fire. These larger plants provide shade and shelter, attracting insects and other animals that help to further enrich the soil and create a more complex ecosystem. Gradually, the forest begins to resemble its former self, but with a renewed vigor and diversity. This process of ecological succession is a testament to the resilience of nature and the interconnectedness of all living things. For centuries, indigenous communities around the world have understood the importance of fire in maintaining the health and balance of their environments. They have used controlled burns to manage forests, grasslands, and other ecosystems for millennia. Today, this ancient practice, known as prescribed burning, is increasingly being recognized as an essential tool for managing wildfire risk and promoting healthy ecosystems. Prescribed burns are carefully planned and controlled fires that are ignited under specific weather conditions to achieve specific management objectives. By reducing the buildup of flammable vegetation, these controlled burns help to prevent larger, more destructive wildfires. In addition to reducing wildfire risk, prescribed burns provide a range of ecological benefits. They help to control insect pests, improve wildlife habitat, and promote the growth of native plant species. By mimicking the natural role of fire in ecosystems, prescribed burns help to maintain biodiversity and ecological integrity. The relationship between fire and weather is a complex and dynamic one, with each element capable of influencing the other in profound ways. Wildfires, in particular, can have a significant impact on local weather patterns, creating their own microclimates and even influencing the formation of clouds. As a wildfire rages, it releases tremendous amounts of heat into the atmosphere, creating powerful updrafts that can rise thousands of feet into the air. These updrafts, known as pyrocumulus clouds, are often accompanied by strong winds and lightning, which can further fuel the fire and spread it to new areas. The intense heat from a wildfire can also cause air to rise rapidly, creating a vacuum effect that draws in cooler air from surrounding areas. This can result in strong, erratic winds that can fan the flames and make it difficult for firefighters to control the blaze. The smoke and ash released by wildfires can also have a significant impact on weather patterns. Understanding the complex interactions between fire and weather is crucial for predicting wildfire behavior, managing fire risk, and protecting public safety. Fire may seem destructive, but some life forms thrive in its wake. Fire-adapted fungi play a crucial role in decomposing organic matter and recycling nutrients. Morel mushrooms often appear after fires, thriving in nutrient-rich ash. Their mycelium thrives in the ash, pushing up fruiting bodies to release spores. The heat triggers morels to emerge and release spores. Charcoal crust fungus grows on charred wood, breaking down complex compounds. It releases nutrients back into the soil, aiding new plant growth. Fungi decompose dead wood, releasing essential nutrients. Next time you see a burned forest, appreciate the fire-adapted fungi. From our earliest ancestors huddling around a campfire for warmth and protection to the controlled burns practiced by indigenous cultures for millennia, humanity's relationship with fire is complex and deeply intertwined. Fire has been an essential tool for our survival and advancement, providing us with warmth, light, and the ability to cook food. The discovery of fire was a pivotal moment in human evolution, allowing us to unlock nutrients from food that were previously indigestible, leading to the development of larger brains and more complex social structures. Fire provided protection from predators, warmth during harsh winters, and a way to shape and manage our environment. Throughout history, fire has played a central role in our cultures and traditions. From the sacred flames of religious ceremonies to the communal bonfires that bring people together, fire has a unique power to captivate and inspire. However, our relationship with fire is not without its challenges. As our population has grown and our impact on the environment has intensified, so too has the destructive potential of fire. As we've journeyed from the heart of the inferno to the rebirth of life in its aftermath, it becomes clear fire is not merely a destructive force, but an integral part of the intricate web of life on Earth. Thank you for joining me, Shaheen Shahabi, on this exploration of fire's profound impact on our planet here on Facts with AI. Don't forget to like, subscribe, and hit the notification bell for more incredible journeys into the world around us. Until next time, keep those minds curious and those imaginations burning bright.